Good morning, this is Ms. Billerbeck, and we're going to talk about 4.1 factorization of ax squared plus bx plus c. A quadratic expression can be simplified to the form ax squared plus bx plus c, where a, b, and c are real and a does not equal 0. So these are real numbers, a, b, and c. So real means that they aren't imaginary. Okay, so believe it or not, mathematicians do have imaginary numbers. So these are real numbers. So a factored version of this quadratic expression would be ax squared plus bx plus c equals, and then we could factor it if we were breaking it down here, where a times c would equal m times m, and b, the middle term here, equals m plus n. Okay, and so then m and n would be the two diagonals or sides of the diamond, because this is called diamond box. So m and m are very important here. So m becomes this diagonal, mx, n becomes this diagonal, nx. So these two can interchange, so don't worry about these two and their position. You could put nx here and mx here. It does not matter which place they go on these diagonals. Okay, this one is always the first term, and this one is always the last term. These matter. So when we go and we factor using diamond box, we're trying to find the area of each one of these squares, or the sides of the areas of these squares. So we're given the area for this square. So we do that by finding the greatest common factor for this column, the greatest common factor for this column, the greatest common factor for this column, and the greatest common factor for this column. And then we add those together, and it usually comes in a form like this. Now this is highly simplified right here for the factored form of this. Okay, this is only if a equals 1, if this equals 1. Okay, so that's the only, this is a factored form only if a equals 1 right here. Okay, we will talk about when a does not equal 1. But first, let's see what happens when a equals 1, because that's the most simple case of factoring. All right, so first example, we have factorize x squared minus x minus 20. Well, first we have to put in what mathematicians always leave out, the 1 coefficient. Okay, so now if we use the diamond, our A, B, and C, so A is 1 times B, C is negative 20, so that's negative 20. B is negative 1, so it falls down here. Then we ask, what multiplies to be negative 20 and adds to be negative 1? Okay, if we don't know, we can do a few things like this. So we can take this and say multiplies to be negative 20. This is my shorthand, by the way, and adds to be negative 1. So if you don't have any idea how to do it, you can just start with the basic factors. So we know we have a negative number, so the larger of the factors is negative. So 1, negative 20, but when we add that together, we get negative 19. We have 2, negative 10. We add that together, we get negative 8. Then we have 4, negative 5, and we add that together, and we get negative 1. So that's our winner right there. Okay, so we can put 4 here and negative 5 here. So now let's do the box. Okay, so the first term goes here. The first term's x squared. We don't really need to put the 1 there. We know it's there. And negative 20. Now this is where this 4 comes in. So we have 4x. So these diagonals are the x terms. And negative 5x. Well, the greatest common factor between negative 5x and negative 20 is negative 5. They're both negative, so we can carry that negative up to our greatest common factor. Between x squared and 4x, that's x. And x squared and negative 5x, that's x. And 4x and negative 20, well, that's 4, a positive 4, so we have a plus here. So we find that this factors as x minus 5, x plus 4. So that's our factors. I probably shouldn't put an equal sign right here because we're talking about expressions right now. Expressions don't have equal signs. Equations have equal signs. All right, well, let's factorize this one. Now we have an a that is not 1 as opposed to this a. So we have b and c. So we do our diamond. We have 3 times 21. And I should warn you, when we first do this, we should check and make sure 3, 16, and 21 do not have any common factors, because diamond box doesn't work well when we carry a common factor through. But if I look at this, this is 3, this is 4 squared, or 2 to the 4th, and this is 3 times 7. So there's no common factor that we can remove. So we are going to carry on with a times c, and then b is 16. Okay, so 3 times 21 is 63. So we look at the factors of what multiplies to be 63 and what adds to be 16. Okay, so we want to choose numbers that might, well, we can do this again. It won't take very long. So we have 1 and 63. Well, what that adds together is 64. We'd have 3 and 21. That adds together is 24. So the next factor would be, let's see, we have 7 and 9, which would be 16. Okay, as we get better at this, we can just see these factors, but this is what you do when you don't see the factors. So you don't have to do this section. This is just a tool for you while you're learning how to do this. So this is 7 and 9. So it adds to be 16, multiplies to be 63. So the box is much more important when a is not 1. Okay, so if you noticed, maybe you noticed, that these ended up being exactly what these were. And that only occurs when a equals 1. So you don't even need the box when a equals 1. But don't tell that many people about that. Okay, so we want them to practice diamond box. Okay, so when a is not 1, we must use this box. So the first term is 3x squared, and then 21. Then we have 7x and 9x. Okay, so we look for our greatest common factor here. Well, 9 does not go into 21, so it's going to be 3. Our greatest common factor between 3x squared and 7x is only x. But here we have 3x squared, 9x, we have 3x. And here 7x and 21, we have 7. So these are addition, there are no negative signs. So this factors as 3x plus 7 times x plus 3. Okay, so we can quickly check that. 7 times x is 7x. 3 times 3 is 9x. 7x plus 9x is 16x. 3x times x is 3x squared, and 7 times 3 is 21. So it works perfectly. All right, so let's factorize this. So we have a, b, c. So a times c goes here. So that is going to be 11 times -5. So that's -55. Then we have the middle term goes here. So we ask what multiplies to be -55 and adds to be 6. Well, 55 doesn't have a whole lot of factors. So we're looking at -55 multiplying and adding to 6. So we just have, it's a positive number, so the bigger number is positive. So that gives us 54. And then the other one is -5 and 11, and that gives us a positive 6. So that you could have done in your head very quickly. So -5 and 11. All right, let's do the box. So first term, 11x squared goes here. Last term, -5 here. Then we have -5x and 11x right here. Now, 11x and -5 have only one factor in common, and that is 1. So 1 is a factor of every number, okay? So don't forget little old 1. Okay, and then we have 11x squared and -5x. So that'll just be x. So we have x plus 1 up here. Now this one we see we have 11x, and this we have -5x and -5, so we have -5. So this one's going to factor as 11x minus 5 times x plus 1. And again, we can check quickly using FOIL. So FOIL is first, so 11x squared, boom, got it. Outer, 11x times 1 is just 11x. And then inner, -5 times x. So 11x minus 5x is 6x. And last, -5 times 1 is -5. So that checks. All right, so there we have it. That is section 4.1. Have a wonderful day.